By the spring of 1945, the war in Europe had entered its final and most chaotic phase. The Allied armies were pushing across the Rhine, cities were still burning, and the thunder of artillery echoed through the valleys of western Germany. Yet behind the advancing lines, a quieter kind of work had already begun. American and British engineers, who for years had destroyed bridges, cleared mines, and carved roads through battlefields, now found themselves doing something entirely different. They were repairing wells, rebuilding pumps, and restoring the flow of clean water to villages that had been dry for months or even years. It was a paradox of the final months of the war. Reconstruction had begun before peace had even been declared. The soldiers who took part in these efforts belonged mostly to the U.S. Army Corps of Engineers and the Quartermaster Corps, often working alongside civil affairs detachments, units created to stabilize liberated areas. Their orders were simple in words but complex in execution: make the land livable again. Many of the regions they entered had been deliberately deprived of water by retreating German troops, who had sabotaged pipelines, filled wells with rubble, or contaminated them with oil and waste. In others, the infrastructure had simply collapsed under years of bombing and neglect. Villagers carried water in buckets from bomb craters filled with rain, or drank from streams polluted by decomposing livestock. For the advancing armies, the situation was not only tragic but dangerous. Without clean water, disease could spread faster than any enemy division. The engineers worked in landscapes that still bore the scars of combat. Burned farmhouses stood beside destroyed bridges. Shattered railcars rusted along the roads. Yet amid this ruin, the sight of men with shovels and measuring rods, rather than rifles, seemed almost surreal. They descended into the dark shafts of village wells, cleared debris with makeshift tools, and tested the remaining water with portable chemical kits designed by the quartermaster's water supply service. They mixed cement, fitted wooden reinforcements, and installed hand pumps scavenged from abandoned depots. What they were building was not part of the military offensive, it was part of something larger, something that pointed beyond the war itself. In the towns of Normandy, northern France, and later across the Rhineland, these acts became small but vital signs of order returning. Reports from civil affairs teams described entire communities gathering to watch the engineers at work, waiting for the first drop of clean water to rise from the repaired wells. When it did, people cheered quietly, as if witnessing the first sign that the war was truly ending. For the engineers themselves, it was a strange transition, from constructing pontoon bridges under fire to repairing village pumps under sunlight. The noise of battle had faded behind them, replaced by the sound of water flowing through pipes. In these moments, war and peace coexisted in the same frame. Trucks carrying explosives passed by others filled with cement and wood. Soldiers who had once destroyed to advance were now restoring what had been lost. The Allies' campaign across Europe was not just about defeating an enemy, it was also about rebuilding a continent in real time, even before the final shot had been fired. In every cleaned well and every drop of purified water lay a quiet truth, that even in the last months of the most destructive war in history, there were those who had already begun preparing for life to begin again. Every liberated village in Europe revealed the same silent crisis. There was no clean water. The front lines moved forward, but behind them lay a landscape where wells had been filled with debris, pipelines shattered by artillery, and reservoirs fouled with oil or human waste. In many cases, retreating German troops had deliberately sabotaged pumps and poisoned wells to deny resources to the advancing Allies. Others had simply collapsed under the cumulative weight of bombing, neglect, and time. The result was a vast, invisible emergency that threatened not only civilians but also the armies themselves. For an advancing division, water was as critical as ammunition or fuel. A single infantry division required tens of thousands of gallons of potable water each day, not only for drinking, but for cooking, medical treatment, and sanitation. The Quartermaster Corps, responsible for logistical supply, could deliver chlorinated water in tank trucks or collapsible canvas tanks, but these mobile systems were only temporary solutions. The deeper problem was structural. Europe's civilian water infrastructure had disintegrated. Rural communities that once depended on wells or village pumps now had none, and the urban networks of France, Belgium, and western Germany lay in ruins. In some towns, no running water had flowed for months. Without access to clean water, outbreaks of dysentery, typhoid, and other waterborne diseases loomed as a secondary enemy. The military's dependence on water was equally precarious. Field kitchens required it to feed troops. Maintenance crews needed it to clean machinery. Hospitals could not function without sterilized water for wounds and instruments. Even the chemical decontamination units that handled potential gas attacks relied on large water reserves. A failure in supply could immobilize entire formations. In the early phases of the Italian campaign in 1943, several Allied units had already learned this lesson the hard way, when contaminated local water sources forced them to halt operations and bring in emergency purification units under fire. Those experiences shaped later planning in Normandy and the Rhineland, but the scale of the problem in 1944-45 far exceeded anything the Quartermaster Corps had faced before. The logistical networks that delivered fuel and ammunition could not simply be converted to carry water. Tank trucks were scarce, and the purification plants established near ports like Cherbourg and Antwerp could not meet the constant demand along the extended front. Engineers resorted to improvisation. They converted damaged fuel trucks into mobile water carriers, filtered river water through makeshift sand beds, and distributed it through steel drums marked potable. Yet such efforts barely sustained the armies themselves. The civilian populations that followed liberation remained largely on their own, drinking from bomb craters and contaminated streams. This created a moral and practical dilemma for Allied command. A starving or diseased population behind the lines could disrupt military operations as effectively as an enemy counterattack. Civil affairs officers warned of the danger. Epidemics, unrest, and dependency on army supplies could quickly undermine local stability. But the quartermaster service, stretched to its limits, could not extend its resources indefinitely. The only sustainable solution was to rebuild, repair the wells, reconstruct the pumps, and restore the water systems that once served these communities. Thus the responsibility fell to the U.S. Army Corps of Engineers and their British counterparts. They were trained to build bridges, not purify water, yet by 1945 these same men found themselves repairing village wells, laying temporary pipelines, and teaching locals basic sanitation methods. What began as a technical necessity evolved into an urgent humanitarian mission. Clean water was not just a comfort, it was the difference between order and collapse. The problem, in the end, was not only about infrastructure, it was about time. Every day without functioning wells strained the Allied supply chain, weakened troop readiness, and endangered the fragile trust of liberated populations. The engineers understood that they were racing against both disease and despair. Their work would not end with victory, because in many places, the war against thirst had already begun before the guns fell silent. The roots of the Allied water crisis stretched back long before the final offensives of 1945. It began in the Mediterranean, during the Sicilian campaign of 1943, when Allied forces first confronted the scale of environmental and infrastructural collapse left by years of war. In the arid terrain of southern Italy and Sicily, where summer temperatures soared above 40 degrees Celsius, soldiers discovered that wells were either dry, polluted, or deliberately destroyed by retreating Axis forces. In the city of Palermo, only a fraction of the pre-war water system still functioned. In rural villages, families drew from shallow pits dug into the ground. The armies could not depend on these sources, and the scarcity of potable water soon became a greater logistical challenge than even fuel or ammunition. To manage these emergencies, the Allied command created the first coordinated civilian military administrative structure, AMGT, the Allied Military Government of Occupied Territories. Established under General Dwight D. Eisenhower's overall command, AMGT combined military engineers, medical officers, and civil affairs specialists with local technicians to restore the essential services that sustained daily life: electricity, food distribution, and above all, water. Their task was not glamorous but fundamental. In the summer of 1943, U.S. Army engineers from the 540th Engineers Shore Regiment and Royal Engineers detachments were deployed to inspect, clean, and repair municipal waterworks in Sicilian towns such as Agrigento and Catania. Reports from the period describe engineers clearing wells, repairing fractured mains, and setting up portable purification units provided by the U.S. Quartermaster Corps. The Quartermaster Corps, which had previously focused on transporting supplies and fuel, was now forced to expand its responsibilities into water purification and testing. Working in partnership with the U.S. Army Medical Department, it developed standardized field purification units, compact filtration and chlorination systems that could purify hundreds of gallons per hour. These systems, often transported in the back of trucks or set up near rivers, became the backbone of water supply during later campaigns in Europe. They included devices such as the water supply trailer for 100-gallon capacity and the ubiquitous Lister bag, a chlorination bag suspended from a tripod that dispensed safe drinking water for small units. The experience in Italy and Sicily revealed that even the most advanced purification technology could not replace local infrastructure. When Allied forces advanced into mainland Italy in late 1943, the same problems reappeared on a larger scale. Entire aqueduct systems had been bombed or sabotaged by both sides. Engineers often had to choose between building temporary purification stations or attempting to restore ancient Roman and medieval wells that still dotted the countryside. Amget field reports from Naples and Salerno recorded cases where engineers cleaned centuries-old cisterns, replaced iron piping with salvaged materials, and coordinated with local workers to restart municipal pumps. By 1944, these lessons had been formalized into doctrine. Each Allied Army group now included dedicated water supply detachments. In the U.S. First Army, for example, quartermaster water supply companies were attached to engineer regiments to test and chlorinate local sources immediately after capture. Civil affairs officers, trained in London and Washington, received manuals outlining procedures for rapid sanitation and water restoration in liberated areas. These documents emphasized cooperation between military engineers and local authorities, reflecting the growing awareness that clean water was a cornerstone of civilian stability and military mobility alike. When Allied forces landed in Normandy in June 1944, they brought with them not only weapons and fuel but also hundreds of tons of water purification equipment. Within days of the landings, mobile water points were established along the beachheads to supply both troops and refugees. But as the armies advanced through northern France and Belgium, it became clear that purified water delivered in trucks could not sustain millions of civilians across hundreds of miles. The only durable solution was to rebuild what had been lost: the wells, pumps, and aqueducts that had once formed the hidden skeleton of Europe's daily life. The work that began under Amget in Sicily thus evolved into a continent-wide engineering philosophy. Liberation and reconstruction had to move together. Every repaired well and restored pipe was a small act of reconstruction carried out in the shadow of ongoing war. These early efforts in Italy and the Mediterranean would later serve as the blueprint for the vast reconstruction programs that followed Germany's surrender, but in 1943 and 1944, they were simply a matter of survival. The turning point came in the summer of 1944, when the Allied armies landed in Normandy and pushed inland through France. The invasion had been planned as a purely military operation, but within days it became evident that victory on the battlefield meant little if the liberated regions could not sustain life. Entire towns had been reduced to rubble, roads were impassable, and the most basic necessities, water, food, electricity, had vanished. The problem was no longer confined to logistics. It had become a question of survival for millions of civilians suddenly caught between destruction and liberation. The Supreme Headquarters Allied Expeditionary Force, SHEF, commanded by General Eisenhower, had foreseen this dilemma in part. Months before D-Day, planners had begun organizing specialized civil affairs and military government (CAs/MG) units to follow immediately behind the combat forces. Their mission was to restore public order, re-establish essential services, and prevent disease and famine in liberated areas. Each of these civil affairs detachments included officers trained in public health, sanitation, and engineering, and they often worked in tandem with units of the U.S. Army Corps of Engineers and the British Royal Engineers. But despite the planning, The scale of devastation after the landings exceeded all expectations. In Normandy's small towns, Isigny, Corentin, St. Lo, and Coutances, water systems had been obliterated by shell fire or mine during the German withdrawal. Civil affairs officers reported that many villages had no water fit for human consumption. Wells were filled with debris and dead animals, reservoirs were cracked and leaking. The immediate response was improvisational. Engineer combat battalions, such as the 254th and 300th, which had originally been tasked with repairing bridges and clearing roads, were ordered to assist civil affairs teams in restoring wells and pumps. It was during these first months after the landings that the collaboration between soldiers and civilians became a defining feature of Allied reconstruction efforts. The catalyst for this shift was not a single directive but the growing realization that clean water was the linchpin of both military and humanitarian stability. Without it, liberated towns could not feed their people, hospitals could not operate, and the Allied supply lines risked being overwhelmed by demands from starving refugees. In August 1944, as the breakout from Normandy accelerated and the front advanced faster than the supply convoys could follow, civil affairs officers found themselves governing vast areas with almost no functioning infrastructure. Engineers began working side by side with local mayors, priests, and farmers to identify old wells, dig new ones, and purify contaminated sources. The French and Belgian populations, weary but determined, joined the effort, sometimes bringing hand tools, sometimes only their labor. Reports from Schaeff's Civil Affairs Division in late 1944 detail numerous cases of cooperative restoration. In the Department of Calvados, American engineers used local limestone to line the walls of village wells. In the Meuse region, they repurposed German pipes for makeshift water systems. In Lorraine, British engineers connected rural wells to temporary pumping stations powered by military generators. The British 79th Armoured Division even documented the use of portable water point units that supplied both troops and civilians from mobile filtration systems mounted on trucks. Each act of repair was small in scale, but together they formed a new kind of front, one where the tools of war were turned toward the rebuilding of daily life. The restoration of water systems became a formalized objective by late 1944. SHAEF directives emphasized the rapid rehabilitation of utilities as a priority equal to security. Civil affairs teams were instructed to restore drinking water within 48 hours of an area's liberation whenever possible. This required constant coordination with engineer battalions attached to the 1st, 3rd, and 9th U.S. Armies. In cities such as Reims, Metz, and Liège, where entire aqueducts had been destroyed, temporary purification stations were built using quartermaster corps equipment originally intended for field use. The civil affairs, engineer partnership evolved from an improvised response into a systematic practice, a kind of emergency urbanism, carried out under combat conditions. By the winter of 1944-45, the effort had spread beyond France. In northern Italy, where Allied forces fought through the Po Valley, engineers worked with AMG, Allied military government, teams to restore wells and pumps in agricultural areas devastated by floods and retreating German demolitions. In Belgium and the Netherlands, where the Battle of the Scheldt had turned the countryside into a flooded wasteland, Royal Engineers drained farmland and reactivated village water points. The technical reports from these regions used almost identical language. No effective civil life possible without restoration of water. The catalyst, then, was not a single order but the convergence of necessity, experience, and human empathy. What began as an emergency measure in Sicily became a deliberate policy in France and Germany. The engineers who once followed the front lines with explosives and bridging equipment were now moving with cement and pipe fittings, tasked not with destroying but with rebuilding. Each well they repaired marked a quiet transition, from war fighting to nation healing, long before the formal peace treaties were signed. The process of restoring wells during wartime appeared simple on the surface, but in reality it was a highly disciplined and methodical operation. It began with reconnaissance, a task that blended engineering expertise with medical precision. When Allied forces entered a liberated town, an officer from the Corps of Engineers or the Royal Engineers would survey the area for usable water sources. Each well, spring, or reservoir was mapped, sampled, and categorized according to its condition. The samples were tested on-site with chemical analysis kits issued by the Quartermaster Corps' Water Supply Service. These kits measured chlorine demand, bacterial contamination, and chemical pollutants, a procedure standardized in U.S. Army Technical Manual TM 10-400. Only after a source passed this initial inspection could the real work begin. Clearing a well was an arduous task. Many had been deliberately sabotaged or filled with debris by retreating German units. In Normandy and the Rhineland, engineers frequently found wells packed with rocks, scrap metal, and sometimes the carcasses of livestock. The first stage involved removing all debris using ropes, buckets, and improvised winches. Once cleared, the walls were inspected for structural damage. Wooden or brick-lined wells often required reinforcement. Engineers used salvaged timber, corrugated metal, or poured concrete to stabilize the shaft. In rural France, where cement was scarce, crushed limestone mixed with clay served as a substitute mortar, a technique borrowed from local masons. After structural stabilization came the installation of pumping mechanisms. Many pre-war hand pumps had been stolen or destroyed, so the engineers improvised with military hardware. Sections of artillery tubing were converted into suction pipes, and vehicle crankshafts were repurposed into pump handles. The U.S. Army Corps of Engineers issued simple blueprints for expedient wellheads, allowing soldiers to fabricate replacement pumps on site using available materials. In other cases, portable pumps driven by small gasoline engines, originally designed for firefighting, were adapted to draw water from wells and distribute it into temporary storage tanks. The purification process was carried out under the supervision of the medical department's sanitation section. Once the well had been cleaned and restored, the water was chlorinated. Engineers added measured doses of calcium hypochlorite or bleaching powder, stirred manually, and then retested the water for residual chlorine levels to ensure it met the Army's standard of at least 0.2 parts per million. Where chlorination was impractical, mobile purification units were brought in. These units, mounted on trailers, contained sedimentation tanks, sand filters, and chlorination chambers. A typical 400-gallon water supply trailer could process enough water for an entire company in a single day. For smaller or remote outposts, engineers relied on the simplest and most iconic tool of the entire operation, the Lister bag. Designed by U.S. Army Major William Lister during World War I, it was a heavy canvas bag holding 36 gallons of water, suspended from a tripod or tree branch. A precise amount of chlorine compound was added, and after 30 minutes the water was safe to drink. Soldiers filled their canteens directly from the bag's spigots. During the later campaigns in France and Germany, thousands of Lister bags were deployed not only for troops but also for civilians, who lined up with buckets to receive clean water from them. Each restored well was marked and logged in engineer records, often with a small sign identifying the unit responsible. Civil affairs officers kept duplicate lists to coordinate usage between military and civilian populations. The engineers maintained a strict testing schedule. Every 72 hours, samples were retaken and examined for contamination. This was not merely bureaucratic routine. Wartime experience had shown that a single lapse in sanitation could trigger outbreaks that crippled entire units. The detailed documentation ensured that, even under combat conditions, every drop of water consumed by Allied personnel met sanitary standards equivalent to peacetime regulations. When no wells could be salvaged, engineers constructed new ones using standard field designs. A shallow well could be dug and lined within a day using prefabricated wooden cylinders or metal drums. Deeper wells required rotary drilling equipment, which the engineers carried in mobile workshops. In Italy and the Low Countries, Royal Engineers used captured German borehole rigs to drill emergency wells near hospitals and supply depots. The process was repetitive, dirty, and dangerous, often carried out under the threat of artillery fire or hidden mines. Yet it followed a rhythm: assess, clean, reinforce, purify, test, that reflected both the precision of engineering and the moral clarity of rebuilding amidst ruin. In the official reports of the U.S. Army Corps of Engineers for 1944 to 1945, These operations were listed simply as utilities restoration, but to those who performed them, they represented something far greater. Each well brought back into service restored not only water, but the possibility of normal life. In the field, the task of restoring water systems proved to be both physically punishing and profoundly symbolic. The men of the U.S. Army Corps of Engineers, the Royal Engineers, and the attached quartermaster water supply units worked in environments where destruction had become the natural landscape. Theirs was not the kind of heroism that appeared in headlines. It was the slow, patient labor of clearing debris, repairing pipes, and coaxing water from poisoned ground while the echoes of artillery still rolled over the horizon. Among the first to gain extensive experience in such operations was the 540th Engineers Shore Regiment, a highly mobile combat engineer unit that had landed with Allied forces in Sicily in 1943 and later participated in the Italian and southern France campaigns. Originally trained to build and repair beach installations, causeways, and supply depots, the regiment quickly adapted to the new mission of restoring local infrastructure under AMGAT supervision. In Palermo and Naples, its detachments repaired municipal pumping stations, flushed contaminated reservoirs, and reactivated the old aqueducts that had served the region for centuries. Official reports from the Mediterranean theater recorded dozens of such projects completed between July 1943 and early 1944, many conducted in extreme heat, with minimal equipment, and under the constant threat of mines or sniper fire. As the war moved north, the 540th was joined by similar units, such as the 254th and 300th Engineer Combat Battalions, operating under the 1st and 3rd U.S. Armies in France. In Normandy and Lorraine, their tasks shifted daily between destruction and reconstruction. One day they might blow a bridge to cut off retreating German armor. The next they would rebuild a well in the courtyard of a bombed farmhouse. In Saint-Lô, engineers restored a municipal pump house that had been shattered by aerial bombardment, using salvaged parts from German equipment. In Reims, they connected the city's surviving pipelines to a temporary water purification plant operated by the Quartermaster Corps. Their work rarely followed a plan. It evolved according to the needs of civilians and soldiers alike. The conditions in which they operated were often brutal. Rain turned the fields of Normandy into mud pits where heavy vehicles sank to their axles. Wells were filled with contaminated sludge that had to be lifted bucket by bucket. Portable pumps clogged with silt, purification chemicals ran short, and chlorine tablets disintegrated in damp storage. Yet the engineers persisted. Field reports from the 1110th Engineer Combat Group described crews working through the night with only flashlights, completing repairs in 12-hour shifts so that nearby hospitals could have sterile water by morning. In many cases, local villagers assisted, women carrying sand, men cutting timber for well linings, children fetching spare parts from abandoned barns. The cooperation blurred the line between liberator and liberated. Both sides were rebuilding together. In the Low Countries, British and Canadian engineer units faced a different challenge: water in excess. During the Battle of the Scheldt and the liberation of the Netherlands in late 1944, widespread flooding had submerged towns and farmland. Royal Engineers drainage units, originally tasked with building Bailey bridges, became emergency water engineers. They pumped out cellars, restored rural wells, and repaired the dike systems that controlled the North Sea tides. In one documented case near Breda, a platoon of engineers used captured German centrifugal pumps to clear a village square and re-establish a potable water point within 48 hours of liberation. The ingenuity displayed in these operations came not from advanced technology but from improvisation under pressure. Engineers repurposed everything. Broken fuel drums became sedimentation tanks, artillery shells were converted into water pipes, and parachute fabric was sewn into temporary filtration screens. The soldiers who had once measured success and destroyed obstacles now measured it in gallons of clean water delivered. The moral dimension of their work was not lost on them. Letters home from members of the 540th and 254th often mentioned the gratitude of civilians who saw, perhaps for the first time, American soldiers digging to save rather than to destroy. The Army recognized the strategic importance of these efforts. Clean water reduced disease outbreaks among civilians, eased the strain on medical services, and stabilized the rear areas essential to maintaining the Allied advance. By early 1945, SHAEF's Civil Affairs Division officially recorded over 1,200 restored water points across France, Belgium, and Western Germany, many of them the direct result of engineer and quartermaster cooperation. The field experience gained during these months would later inform the U.S. Army's post-war manuals on disaster relief and reconstruction, a legacy born not from laboratories or command offices, but from muddy fields and shattered wells. For the men who performed this work, the satisfaction was quiet but lasting. They were accustomed to building under fire and repairing under rain, but in the ruined villages of Europe they discovered a new purpose. Each restored well was a small act of defiance against the destruction that had consumed the continent. Where water flowed again, so too did the sense that life, against all odds, could continue. The restoration of wells and water systems had effects far beyond their immediate technical purpose. What began as improvised fieldwork by scattered engineer battalions soon evolved into an organized component of Allied occupation policy. Every repaired well and pump reshaped the relationship between the advancing armies and the civilians whose towns they entered. The flow of clean water did more than sustain the troops. It symbolized the return of stability, order, and human dignity in a landscape where all three had nearly vanished. In liberated villages across Normandy, Brittany, and the Low Countries, the sight of soldiers working not with rifles but with shovels became a quiet but powerful message. Civil affairs officers noted in their reports that when the first restored wells began operating, cooperation from local populations increased dramatically. Farmers began volunteering wagons and horses to assist the engineers. Townspeople shared building materials and local knowledge of hidden cisterns or underground pipes. The act of giving back water was seen as a gesture of goodwill, signaling that the foreign troops were not conquerors but caretakers of recovery. The practical impact on military logistics was equally significant. Before the widespread restoration of wells, the Quartermaster Corps had been forced to divert thousands of gallons of fuel to transport water in tank trucks over long distances. Each local water source brought back into service meant one less convoy vulnerable to air raids or supply shortages. In operational terms, every well repaired by the engineers saved fuel, reduced disease, and allowed divisions to move faster and with greater autonomy. Commanders in the field soon realized that water restoration was not a distraction from combat operations, but a form of strategic efficiency. By late 1944, the results were visible enough that SHEF headquarters formally incorporated water rehabilitation into the standard civil affairs stabilization checklist, alongside food distribution and sanitation. The directive summarized the mission in 3 words that became the motto of CAs/MG detachments. Feed, water, restore. Civil affairs handbooks issued in the winter of 1944 to 1945 included specific guidelines for collaboration between local authorities and engineer units. These instructions detailed how to survey wells, test for contamination, distribute chlorination supplies, and prioritize repairs based on civilian population density. In France, Belgium, and Western Germany, the U.S. Army Corps of Engineers created semi-permanent water sections within its combat groups to handle increasing requests from civil affairs. Units such as the 254th Engineer Combat Battalion and 1110th Engineer Group reported dozens of projects completed each month, ranging from the cleaning of village wells to the reactivation of entire municipal waterworks. Many of these sites bore simple wooden plaques reading, "Repaired by U.S. Army Engineers," left intentionally as a mark of gratitude and reassurance. In occupied German towns like Aachen and Cologne, similar signs appeared in English and German, signaling a new kind of contact between former enemies, reconstruction under military supervision. The British and Canadian sectors developed parallel practices. The Royal Engineers Field Utilities Sections operated portable purification stations that supplied both military camps and nearby civilians. In Belgium, these efforts expanded after the Battle of the Bulge, when thousands of displaced residents returned to find their towns stripped of infrastructure. Reports from the British 79th Armoured Division mention cooperation between engineer units and local fire brigades to distribute water from reconstructed wells. In the Netherlands, where flooding had rendered groundwater undrinkable, engineers installed shallow filtration basins and manually pumped clean water for both soldiers and civilians until permanent systems could be restored. The impact spread not only geographically but institutionally. Civil affairs schools in London and Paris began incorporating case studies from Normandy and Italy into their training programs. Officers were taught that water was not just a logistical matter but a tool of pacification and public trust. This doctrine was later codified in Schaeff's Handbook for Military Government in Germany, which emphasized that the restoration of utilities was essential to preventing unrest and disease. The well thus became both a symbol and a strategy, a point where engineering, governance, and humanity converged. By early 1945, thousands of local water points across Europe were functioning again because of Allied intervention. In many towns, the first clean water available since 1940 flowed from a spigot repaired by soldiers. The act of turning that handle carried immense psychological weight. It meant that life, in its most basic form, was returning. Where the wells worked, so did everything else. Schools reopened, bakeries resumed production, and the population began to recover from years of occupation and scarcity. In the official records of the U.S. Army Corps of Engineers, these achievements were logged as minor utilities projects, a technical term that failed to capture their human importance. But in the collective memory of post-war Europe, they marked the first signs of a future built not from victory parades, but from the steady rhythm of pumps and the sound of water filling buckets. The legacy of the Allied engineers' work extended far beyond the immediate needs of wartime survival. When the guns finally fell silent in May 1945, Europe was a continent of ruins, its bridges broken, cities gutted, and infrastructure on the brink of collapse. Yet amid that devastation, one foundation for recovery was already in place. The engineers who had spent the last years restoring wells, repairing pumps, and purifying water were among the few who understood, in practical terms, how to rebuild a functioning society from the ground up. Their wartime experience became a blueprint for peace. The U.S. Army Corps of Engineers, along with its British and Canadian counterparts, retained detailed documentation of their water restoration operations. These reports, originally written to track logistical efficiency, soon found new value as technical manuals for reconstruction. Civil affairs officers who had overseen local utility projects were reassigned to post-war occupation governments in Germany, Austria, and Italy. Their field notes, sketches, and procedural guidelines were compiled by the Office of Military Government, OMDIS, into the Public Works and Utilities sections of early reconstruction plans. In many German towns, the first civilian water departments were staffed by former Wehrmacht or Allied engineers who had worked together under military supervision. The continuity between wartime repair and peacetime recovery was immediate and tangible. The engineers themselves carried this experience into civilian life. Thousands of veterans from units such as the 540th Engineer Regiment and the 254th Engineer Battalion went on to careers in public works, sanitation, and municipal engineering. Their field training, reinforcing shafts, disinfecting contaminated wells, building temporary filtration systems, translated directly into the peacetime tasks of restoring cities and rural infrastructure. Many took part in projects funded under the European Recovery Program, better known as the Marshall Plan. The U.S. Army Corps of Engineers, now functioning as a key technical agency in post-war Europe, applied the same methods once used in the field: small-scale, modular repairs executed quickly and efficiently. In France and the Low Countries, hundreds of village wells first rebuilt during the war became the nuclei of expanded rural water networks constructed in the late 1940s. In Germany, where the destruction of water and sewage systems was nearly total, Allied occupation authorities relied heavily on the expertise of the engineers who had worked under civil affairs during the final campaigns. The technical manuals they produced in 1945, covering everything from chlorination standards to emergency pipeline repair, formed the basis for post-war public health and infrastructure reforms. The U.S. Army's experience in field sanitation directly influenced the design of new municipal treatment plants in cities like Frankfurt, Hamburg, and Cologne, where temporary wartime water points were later converted into permanent installations. In Italy, AMGAT-trained engineers collaborated with local municipalities to reconstruct aqueducts dating back to the 19th century, blending ancient designs with modern techniques introduced by the Allies. The influence of these efforts also shaped military doctrine. In the years following the war, the Corps of Engineers incorporated lessons from 1943 to 1945 into its peacetime mission, establishing new branches for disaster relief, flood control, and civil engineering support. Manuals such as FM 5-10, Engineer Field Manual, Engineer Troops, and TM 5-650, Water Supply, Sources and Purification, reflected a shift in perspective. The engineer's role was not limited to combat, but extended to humanitarian and civil functions. The Royal Engineers made a similar transition, formalizing utilities sections within their organization to provide emergency public works capabilities during both military and civilian crises. Even decades later, traces of this legacy could still be found. In rural France, Belgium, and Italy, villagers pointed to wells inscribed with simple metal plaques reading, "Repaired by U.S. Army Engineers, 1944-45. Many of those wells continued to serve their communities well into the 1960s and 1970s. Local municipalities, recognizing their historical significance, later protected some of them as heritage sites. These restored wells stood as quiet memorials, not to victory or destruction, but to the moment when soldiers turned from war to renewal. The moral weight of this legacy was not lost on those who lived it. In post-war interviews and unit histories, veterans of the engineering corps spoke less of the bridges they blew up and more of the wells they rebuilt. For them, the sound of water flowing again through a pump was a symbol of redemption, proof that their skills could heal what war had broken. It was a rare chapter in the story of conflict where the mark left by armies was not a scar but a source of life. The story of the military engineers who rebuilt wells before the war had even ended revealed something deeper than logistics or necessity. It showed that victory was not defined by the moment when enemy flags were lowered, but by the instant when human beings began to repair what had been broken. Amid the rubble and exhaustion of Europe in 1944 and 1945, the act of digging for water carried a meaning far greater than survival. It represented an instinct as old as civilization itself, the will to restore life to the land after destruction. For generations, war had been seen as the ultimate expression of power. But in the final months of the Second World War, the engineers proved that true strength lay elsewhere. Their mission did not involve strategy or glory. It involved patience, precision, and compassion, virtues rarely associated with the battlefield. Each well they cleared, each pump they repaired, was a quiet rebellion against the very logic of war. In places where everything had been poisoned, they chose to purify. Where the enemy had filled wells with stones and corpses, they chose to cleanse them. Their work turned the language of warfare on its head, the tools of destruction became the instruments of renewal. For the men who performed these tasks, the change was not merely professional but spiritual. Many of them had spent years building fortifications, laying mines, and demolishing bridges in the name of victory. Now they found themselves using the same hands to rebuild. Letters and memoirs written by American and British engineers after the war often carried a tone of quiet revelation. They described the moment when water first rose again from a repaired shaft as one of the few times during the conflict when they felt they were creating rather than destroying. That transformation, of soldier into builder, of war into healing, was as profound as any political victory. The image of soldiers drawing water from the earth while the war still raged became a symbol of moral clarity in an age of mechanized chaos. It suggested that progress was not measured by new weapons or conquered cities, but by the human capacity to preserve compassion even amid devastation. When viewed through this lens, the engineers' work was not a side story to the war. It was its moral conclusion. It affirmed that civilization survived not through conquest, but through the restoration of trust, cleanliness, and dignity, the basic elements of life itself. Historically, their actions foreshadowed the coming transformation of the Allied mission from liberation to reconstruction. The same soldiers who had fought through Sicily, Normandy, and the Rhineland would later help rebuild the societies they once shelled. The shift from combat to construction marked the beginning of the modern humanitarian ideal within military operations. Long before the establishment of NATO's disaster relief mandates, or the United Nations peacekeeping missions, there were engineers on their knees beside broken wells, proving that the first duty of power is to serve life. In the decades that followed, the legacy of those quiet acts endured not only in the infrastructure they restored, but in the moral architecture they helped build. The wells they repaired continued to supply water for years, but their true significance flowed elsewhere, into the realization that victory without compassion is hollow, and peace without reconstruction is fragile. The engineers' work stood as a reminder that the greatest human triumphs are often the least celebrated, not the battles won, but the lives made possible afterward. In the ruins of Europe, where so much had been lost, the simple sound of clean water running through a pipe became a kind of hymn to survival. It marked the moment when history, for a brief instant, turned from death back toward life. And in that moment, long before the treaties were signed or parades began, the engineers of the Allied armies had already built the first foundations of peace.